discussion.
Well, yeah, thank you for joining. It's part of.
Yeah. Tell me.
I set up the foundation called Genomic Medicine
Yeah,
Foundation.
that's right.
And all my activities are now within that foundation, including my current UK-India Genomic Medicine Alliance.
Yes.
I started Indo-UK Genetic Education Forum, as you know.
Yeah.
There's so many other activities, books, journals, and all those things. And so I started this foundation in 2015 with the help of Sir David Weatherall. You might know the big name. He passed away.
Yeah.
He was patron. Yeah. He passed away last year. So the current patron is another famous man of pharmacogenomics, Munir Mohammed.
Oh, Munir. Yeah.
So he is a current patron. So we have set up an academy within the foundation. So we have got about 30 people from all over the world. We are recording their lifetime achievements. So you are one of them. So that's why I approach you. So,
okay. No problem. So tell me what I'm supposed to do.
Very informal, just to go through your early life, early career, and major research, major achievements. So it's very informal. You can start let's start from, and also I'm recording it because we'll post it on the site. So there are no, you can certainly keep information that you don't want to publish, or post. It's entirely up to you.
So you will have a voice podcast, or you will have a video podcast?
It will be video.
Okay, just to get an idea.
Yes, and like I'm recording now. So tell me, Samir, we have known many years now. I think going back, I think 2008. I think 2008 when I met you first time. Or maybe.
Yeah, I think so. Or maybe before. I think we met once more before in Weatherall was here. There was a conference in which I think I met you.
So I think more like 15 years, I would say. When you were director of the IGIB.
That's right. That's the time we met.
I think I remember my first contact was when I was working on my book in genetic disorders of the Indian subcontinent. And then I think we could not contribute because of time factor. But the second one, the large book.
That's right.
You contributed. So that's very good. Thank you very much. So just tell me, Samir, about your early life.
Okay. Yes. I've been, thank you, Dr. Devendra, for requesting me to participate in this wonderful initiative, walking back to the memory lane of life.
Yes.
And it also coincides with a beautiful time because I came to Delhi from Bangalore to establish genomics in India.
Yes.
And this month, before Christmas, I returned back to Bangalore. And after spending 23 years as a young student master's in Calcutta with physical chemistry, I came to Indian Institute of Science to do PhD in biophysics when G.N. Ramachandran was the tall man there. And then I spent 23 years in Indian Institute of Science, Bangalore, where I joined as a student, then went up all the way to a professor. And so when I was a student, I had only one dream, that I should be able to use the letterhead of Professor Ramachandran and write Professor of Biophysics in the Institute of Science. So when I achieved it, I thought my job in Bangalore is done. By the time genomics was very high, I was lucky that my entry to genomics was purely accidental. My interest was in nucleic acid structure, and especially interest was in the repetitive DNA structure function when I became faculty in 80s. And although my early work was in peptides and spectroscopy, structure of collagen, and I worked on publishing many, many papers, so I could get a faculty position at Indian Institute of Science, being the first student of the department to be a faculty of that department.
That's great achievement.
So I had an offer to be, I just came for a short period in Paris because the position was on biological chemist who will do biophysics. So I came to learn little molecular biology in Institute of Giacomo in Paris, University of Sète. But within 1 year, I decided to go back, as they said, Professor Sheshik had said that you will get a job, you come back. I had an offer to go to Charles Cantor's laboratory, 1979, but I decided to come back to India. Of course, many people thought, because I have my girlfriend in Bangalore, she was doing a PhD. She was from Karnataka. That's why I came back. Yeah. But I was very clear that I want to do science in India. And unlike many of my colleagues, and I have seen G.N. Ramachandran doing world-class science, Shekhan doing world-class science. So I had no doubt. I've seen C.N.R. Rao doing world-class science. So I had no doubt that it is possible to do world-class science. You create your own ecosystem and you build it.
That's correct, yes.
So at Molecular Biophysics, I started on DNA structure and function, and with special focus on repetitive DNA. It has a historic perspective. 1980, Francis Crick and Orgel published a paper in Nature saying that junk DNA. And these repetitive DNAs have no biological function, and any work on them will be intellectually sterile and futile exercise. I realized that I'm a structural biologist.
That was Francis Crick who said that.
Francis Crick and Orgel. So I knew nobody will get funding, neither in Europe or America, to work on repetitive DNA with that article. So I got my CSI, first Indian National Academy Young Scientist Medal, so I will get grant. And my grant was on how to do repetitive DNA structure function, okay? So I thought it's a good bet. If I put my bet on something, I'll be able to publish papers and all. And if it is right, I'm the early mover.
Yes.
And if I'm wrong, it doesn't matter. So with that, I entered the repetitive DNA. So that's how my entire understanding that DNA can have multiple structures, hairpin loops, slippage, triple helix, and those work started. And the zDNA was just in the air. So I wrote the second paper on the zDNA to show that how structural transitions are possible inside the cell. And those are the early days work that brought the attention of Charles Cantor. So I discovered that the restriction enzymes are not only sequence specific, they're also structure specific. So I could create artificially supercoiled structures inside the cell, and in vitro, in vivo, I could demonstrate. I could also demonstrate that the zDNA, long stretches of CG-CG repeat, is not polymerase, gets stuck. It doesn't move. And methylation inhibits it much more because of the structural inhibition. So when that happened, I was looking for enzymes to work on, and this is the time my wife decided after her PhD to spend a year in Vista Institute in USA with Devor Salter to do micromanipulation and injection. Those are the early days of cloning. And Charles Cantor said, you never came to my lab to do postdoc. Why not you come as a visiting scientist? So I decided, okay, let me go for a summer. This is the only summer I spent in New York, in Columbia University in 1985. And it just turned out, during my stay, Charles Alesi invited Charles Cantor and others to discuss about potential human genome project. I still remember the first night when Charles came back from Washington. He took me out with another colleague for a dinner. And it was very exotic Japanese dinner, so I couldn't eat any food. But I was shocked to see that these people are dreaming to genome sequencing. By the time Seward's PhD thesis was in Charles Cantor's lab, where he showed pulse field electrophoresis to separate DNA at the mega scale. So I could see the pieces in place. Here is a PCR, here is YAC cloning, here is pulse field electrophoresis. But dreaming of doing a sequencing of 3 billion nucleotides, it was shocking. And next 4 weeks, or 8 weeks, I was there for 3 months. Every week, Charles goes to Washington, comes back and explains me what exciting it will be, how DNA will be done, how things, So it was a very, very serendipity that I landed up there. Really? And since I had, I was just a non-competitor, but I'm a good listener and discussant. So there was no intellectual property worries anybody had. But I had the chance of meeting Zim, Brad, all these people at the very beginning in various dinners along with Charles Cantor and learn about it, okay? So I came back to India and I tried to convince, but people didn't understand that what it means for. And I was very clear that we should do mycobacterium, some bacterial genome. So 87, I held the first genome workshop in India, in Institute of Science. Using how techniques can be used for genome analysis. So by 1990, I got elected to the Hugo. I also did the first large-scale genome DNA sequence analysis, which was all available. There was no gene bank, there was no database. It was all from published papers. You had to go through hundreds of papers. I could demonstrate that the TG repeats are in the introns and CG repeats are absent in the genome most of the cases. There's no CG6 in the whole genome. That time it was 2 million mouse and 3 million human genome sequence was there based on that. So, that's how my interest built up. And by the time I solved the structure of telomere repeat, and then that became very, one of the most cited classic paper. And Charles Cantor then, and I think I went to also Soviet Union, 1988, and came to England in 89, met Edward Southern. I saw him printing oligonucleotides on glass. I said, oh, mad guys. Then I saw they will do DNA sequence. Then I met Andrew Mirzabekov in Russia. I was there for every year. I used to go for 15 days. And he is putting hexanucleotides on gels, acrylamide gels, to create what eventually became Affymetrix, right? So Drummond and others. So my exposure was very, very exciting because these are all physical, biophysical chemists, nucleic acid chemists who are putting their best mind, and that's why they called it reverse genetics. Geneticists were not so excited about it that time. It just happened to be that way. Then the Human Genome Project was launched and Hugo was formed, and I got elected to Hugo in 1990, the first batch of people from this part of the world. So one of the best part of Human Genome Organization was that the information dissipation. I was now collecting to write a book. I actually have those newsletters of issues of newsletters used to come because there was no internet days, there was no Google to search. Yeah. So what I meant is my exposure to genomics, I suddenly realized I started working repeat. So my trinucleotide repeat work suddenly got an importance when Fragile X and myotonic dystrophy appeared. Myotonic dystrophy was very, very exciting because it is a 3' CTG repeat at the end of the gene. And why does it block transcription? So that time my work was already published, that how transcriptional blocks can take place with slippage structures. And so I proposed that model. So that brought me to Dr. Gauri Devi at NIMHANS to get some myotonic dystrophy patient. I sent the paper to Nature Genetics, and the reply was, are you sure that structural things will cause a genetic disorder? I replied saying that Max, Peyrut and Kenru has shown it does. But, I was still not a genetics group, so it was not okay. So then I just started looking at. So that is how I built my ataxia project, because it came from my interest in repetitive DNA. And then, of course, database came, East Genome. We analyzed the first set of the genome. And then I wanted people to tell that this genome is going to be the future. Health and genetics will be the future. By 95, 96, Craig Venter has joined in. So I met Craig Venter. I met William Hasseltine in Human Genome Sciences. I had the privilege of knowing Aaron Klug very well. And he was a great admirer of my telomere work. By the time he was the president of the Royal Society. And then he was very excited about the triplet repeat and structure. So I knew when one man says it is important, that's Aaron Klug, I don't have to worry about anybody else is saying whether it's important or not. So that's why the journey of ataxia began. In between, I think I heard a lecture of Weatherall when there was a Ranbaxy award I received. And I suddenly realized that all Indian, hemoglobinopathies are analyzed by him. Okay, so I had an interest in globin gene because 75,000 of this nucleotide sequence was available. I realized that it is an interesting gene expression structure, yes, because you know very well, fetal, then embryonic, fetal, then adult. How does it switch? So my interest was how is switching, gene expression changes take place. So I went to Calcutta, Ramakrishna Mission Hospital with Geeta Talukdar, you might know him, and was interested to get some samples of thalassemia patients who has 3% fetal expression for which they need less blood transfusion, okay? They need once in 6 months, unlike others who need every month. Pure academic interest, nothing else in mind, no serving to humanity. I went to get those samples. And then I was saddened to see that the parents coming with the second child with thalassemia, and there are no tests. So I said, why there's no test? It's so simple, PCR and all. Then I was told that I have to send the sample to Bombay, and from Bombay to Weatherall's lab, and it will cost Indian rupees, 10,000 rupees per pound, you cannot fit. That day I got transformed. I suddenly realized that I have been only working for myself. And here is, I have the PCR machine, I'm running the oligonucleotide facility of Indian Institute of Science, I have the sequencing machines. I will spend 20% to solve thalassemia. So that's where my first early work started on thalassemia sequencing, identifying 5 major mutations, convincing Bangalore Genie to make primers, and then eventually commercialize it. And I think 97, 98, one of the thalassemia meeting, I was invited to give a talk, and I was presented with 16 children's face photograph who were born healthy out of carrier parents who had used my indigenous developed thalassemia primers. Okay. Same way, Dr. Gauri Devi pushed me to develop applications for genetic testing for various ataxia and also Duchenne muscular dystrophy. Yes. So then I realized it's just not possible from a single laboratory sitting in Bangalore. I need an institution. Mm-hmm. And I tried to build something in Bangalore, wanted to build a foundation, but it was not, it didn't work out. And that's the time I was invited by Max Planck to come and start a laboratory in Göttingen. So I was in Germany in 1996. That is the time when Human Genome Project had a lot of controversy about ethical issues. These samples taken from third world countries and things should not be made guinea pig. So I was like an activist because I understood when the genome sequence is over, to understand complex diseases, you need populations with large family structures, right? And China cannot do that with one-child family. India will be the heaven for those discoveries, right? So we need to preserve Indian genetic material. And that's where I became a little activist. And eventually, I was invited in Germany to give a lecture in the Bar Association, International Bar Association, when Hugo had a medical genetics session to discussing about the ethics of human genome. And they didn't find a lawyer in India. They found me. They thought I'm a lawyer, but I was not, right? And that eventually rolled me to come in. I'm a member of the with Justice Kirby committee, which is the chairman from Australia. He was justice, and Barbara Nuppers and others came in, and there I met Hu Ming Yang, and I became a member of the Human Rights Commission's International Committee of Bioethics, and which eventually said that you need to give it benefit back to the population. And so that's how, by 97, actually, you will be surprised that 97 May, I arrived in Germany for 3 months to give a try to stay in Germany, because they offered me that you will be a director of the Max Planck and all, because they are retiring, they will build a lab. And that's the time in July, I was called from Delhi that you have been selected as a director for this Institute to Build Genomics. This was the second event. The first event was in 1990, when I went to Lawrence Livermore back, when Charles Cantor moved to Berkeley. He invited me that you come and join me, and then, you will be adjunct associate professor in the university, and you will be in Lawrence Livermore. So I went in June, and I agreed. And I said, okay, next April, I finish 10 years of my service in Bangalore. So me and my wife both will move. And September 26th, CSIR announced Shanti Sharu Bhatnagar Award. I was 38. At this age, hardly people get it. Maybe Sienna Rao is one younger person than me who got it. So I realized that now if I leave, I know that genomics is the future. My grandchildren will tell me that you knew about it, but you left. So I told to Charles Cantor, sorry, I'm not coming. So, in life, I say, you may have a dream, you have a drive, but eventually destiny drives you. So the destiny has prevented me to have a beautiful place, like you are enjoying. Today, somebody, my friend, who has sent beautiful pictures of fall colors from USA. I was telling my wife, see how clean the air is, how beautiful it is. And, so I said that it was not there, me to be in that part of the world. Okay, occasions didn't. So that brought me to build the CBT to IGIB, the Institute of Genomics Integrative Biology. I think there are 3 principles I used. I re-engineered a laboratory. I picked up research problems will be important 20 years ahead, not that day. So we picked up complex disease, diabetes, asthma, neurological disorders, psychiatric disorders, and said that we presume the genome sequence will be available in public domain. So we are not going to spend our little money of $2 million in doing sequencing. We will collect patient samples and we'll build informatics, because these are the 2 resources that India was good at.
Yes.
And this is where IGIB today stands. That's how you will see that so much of work has been done on ataxia, so much on then the sequencing, then the Indian Genome Variation Project. So one by one, we built it up. And I was very clear that China will do the sequencing, we will do the analysis. We are not going to spend our money on sequencing until sequencing becomes cheap, because human genome eventually will be public domain. And that just turned out to be true. So we were early mover on analysis. That's why you see today analysis is the bottleneck of the genome sequence. And today you are using artificial intelligence and other methods. And of course, we followed that, how to convert every knowledge into application.
Yes.
And I'm very proud to say that what I built started 23 years back. The institute, my younger colleagues whom I recruited, they have grown. Several of them are national heroes and leaders who contribute to your books. And, and the younger generations have been not only able to do things what we plan to do, but even this year during COVID, we converted all our knowledge and could do so much of sequencing-based data generation that allowed us not only to become a major referral center for India, but also to see how the disease pattern is moving and how the mutations are occurring, and eventually come up with a technology which is Casper, Cas9 based technology to do what you call Feluda, which is one of the low-cost, high sensitivity techniques.
Amazing.
So you see, that was developed to take care of sickle cell anemia, and we converted that into this.
In the beginning.
Yeah. So therefore, you can see it's a great satisfaction. If you ask me the life journey, in science, you can achieve many things yourself. But I have seen many scientists who have kept himself focused on himself. Since you said lifetime, I wanted to say that when I got Indian, fellow of the National Academy, Indian National Science Academy, you take an oath that you uphold the humanity. At that point, I thought humanity means so for myself, my next grant, my next international lecture, my next paper, my next award. When did I think about the world? In 95. So you can say you can break my scientific career into two phases, pre-95 and post-95. Pre-95 is all to pursue excellence and achieve things. And post-95, as an enabler, how do you make visions convert into reality and make it happen? So I think at this point in 2020 December, it's a great satisfaction that, I will, before I enter the aircraft, I will get COVID tested using the technology developed at my institute. This is a very rare occasions one get. And even the people who will come for packing or people who are visiting me, they're all getting COVID tested in my institute. They said, we don't want to give you infection. So, this is a great satisfaction that science that you built, the people you built, they have achieved it. And I think it is far more satisfying than yourself picking up some awards and fellowships, international fellowships, by sheer doing science yourself. After IGIB, I had to take up to as a DGCSIR. So that was another phase for 7 years, 2007, 10 years of directorship. Not only I could help IGIB, but I could build the India's largest university system without government funding, that is the Academy of CSIR, which has 2,000 plus faculties and 5,000 PhD students. Already it has produced 2,000 PhD students since 2012. So this is, I think, and then I started the open source drug discovery movement. And that is the genome sequence for TB was available. And how do you make drug discovery open source? So that is open source drug discovery, OSDD, which is very well recognized, accepted. And that was to build a system biology model for tuberculosis. And to know that there are 890 genes using 1,152 reactions using 961 metabolites. How does it work? To put all in computer and knock them out in computer and find for repurposed drugs. So you'll be happy to know that today some of those discoveries are in clinical trial. And one of the drug was metformin as an adjuvant for TB because it reduces the drug resistance of isoniazid. So that also is under clinical trial along with the bedlaquine drug to prevent drug resistance. So, and then of course, as a DGCSIR, you create large-scale programs and plans, bring larger money, so bring more resources and recruit the best people. So I will say at the end, it has been a great journey.
Yes.
And also I found out finally people matters. Resource doesn't matter. And the ecosystem you create yourself.
No,
Many people say the ecosystem is not there, but...
Sorry to interrupt. I think resource does matter, and the resource and the infrastructure does matter. Then, yeah, that's very important. I think, as you said, you pre-95 and post-95. There's a very good separation of your. In fact, you have more than two phases of your life, which are knowing you from as an observer from outside. Because I've met you many times, Hugo and non-Hugo and other places.
Yeah.
I've read about you. I think my passion, as you know, as a clinician, I mean, for me, so I also came to medical genetics, but by accident. And think
yes,
when I was in Lucknow, after MD in pediatrics, I had a small grant given by CSIR.
Right.
In collaboration with the Professor Dr. Khushu, who was National Botanical Garden Director in Lucknow. So he had a small cytogenetic lab, but so I got him interested to children with Down syndrome mainly. I think he had a relative. I think he had a relative whose son was born with Down syndrome. So he came to department. Then I think I came to know him then anyway. So I got a grant, but when I got the grant, I came here, so it was used by somebody else. My take, like you were saying now, it is the giving away, what do you call, the translation or application that matters. If the science has no outcome, and then I think the science has no value. I mean, still got a famous Gandhi quotation. If the science does not reach masses poor, has no purpose.
So, to me, whether you get a fellowship of a foreign academy is less important. Then I can say so many thousands of people's life got touched. And that's a very important. Today, Indigene program, our Guardian and all these programs, GOMED, is benefiting so many people. So many people's life it is touching. And today, all of my neurological disorder diagnostics, my younger colleagues have made it final. And then Lal's Path Lab is using them, it's providing the service. So it's all technology gone to the masses. And but, finally, I think if you ask me the future is to understand biology in structural terms. The way Max Perut and Ken Rue understood one disease process, hemoglobinopathies problem. How does this hemoglobin, myoglobin problem, mutations, and to this population genetics level, why malaria protection when you have sickle cell, heterozygous. So all this, actually in biology, you need at this moment, maybe 500 to 5,000 Max Perut and Ken Rue to understand in structural terms, understanding biology. And I am sure the UK DeepMind and Google with the artificial intelligence, and that's what I'm most exciting now.
I think resource, again, coming back to resource, and that's where we need our younger people to different aspects of genomics, not only one area. But I mean, those who are IT experts, they need to really go into artificial intelligence. We need those people, bioinformatics. Really.
So, that was two things. As I said, I was the first molecular biology, structural biologist to connect to doctors. So I realized that we should have a network of doctors. So I started from Ramalingo Swami to Gauri Devi to Sanjeev Jemnimans and all AIMS. That plethora of doctors got connected from Gauri Devi to our Geeta Talukdar in Calcutta. So I connected to doctors first. So I had the privilege in late 90s to give lectures both in Congress of Thalassemia Congress or in Neurology Congress or in Psychiatric Congress. And I used to jokingly say that in NIMHANS, the neurology and psychiatry are two sides of the road. So I used to say, you must have a tunnel below, because genomics tells it is the same gene, can cause epilepsy or can cause psychiatric disorder. When you do lithium therapy, you actually don't know which one you are handling, or olanzapine can act for this as well as for this. So, this time when I went to NIMHANS to give a lecture, Gauri Devi oration lecture, I saw they have formed a tunnel. So I said, genomics brings tunnel across the medical system, because medicine, we have partitioned knowledge.
Yes.
We have completely partitioned knowledge. Genomics tells it is holistic. Body is a holistic organ. It is not, and this is where our failure of understanding of many disease process. And you can see for COVID, we are not able to understand why this one simple virus reacts so differently to different people.
I think that's my theory also, and working on genomic medicine after a few books and all those things. I still talk to people. We have created boundaries unnecessarily. We have divided medicine into compartments. It doesn't like that. You see, you have to have a common approach. So my my take now is what I call molecular medicine.
Yep. And I tell you one more thing that you all should push to create.
So if I show you this book, so this book I have not used like a body systems. I've used molecular systems.
Yeah.
Underneath the molecular system, there are genes and genomes.
Yeah.
All variables. And it has come out very nicely. As you can see, I mean, this is I'm very pleased.
Show the book once more. I will take a snapshot.
No.
Yeah. Once more, it is not taking the. It is not coming to the camera.
Is it okay?
Yeah. Take it.
So I think I mean, this is and my new series, which actually I just got yesterday, 25-volume series on genomic and precision medicine. And CVR has commissioned. I got contracted. 25 volumes.
Wow.
Samir, I will ask Vinod Skari. Vinod Skaria.
Vinod Skaria is my student only, no?
I know you told me. I'm not written to him, but you can sound him. And I'm for rare diseases section of the book series done by IGIB. I'm very serious about that.
I will be very happy, because now I will be free person when I go to Bangalore.
This is
so I will have. So I should be able to help you on this matter.
This is my foundation, our foundation. I mean, this 25-volume series on genomic and molecular medicine would be like actually it's a dynamic field. Today's I think the concept will be there.
Yet I tell you, one of the major bottleneck I'm seeing is that we have kept our clinical trial in 1946. We have to bring it down and say there is a genetic variations of people, and we must look at drugs which will respond people differently, and therefore not doing a genotype-based clinical trial. I think we are doing a damage to the system.
Exactly, I agree. People are surprised why the vaccine of the COVID-19 vaccine and diagnostic testing is successful, because we ignored the red tapeism, the past red tapeism.
Correct.
All those artificial blocks what were created in the old. That's why trials were so expensive, and took many trials did not produce anything. Now, because of the emergency, because of pandemic, people realized, and the society and the politicians agreed. That's how we have achieved. I think it's a turning point. It's reminder for future.
Yep, absolutely. I wrote an article along with Charles Offray and around 80 odd authors that here is a time now we need to build an open innovation platform for healthcare, for well-being and affordable healthcare. You cannot run the same way that we have been running. And I will be very happy to contribute anything you want me to contribute on this. So
the objective of my UK-India Genomic Medicine Alliance is to together. I mean, recently, I was invited as a panelist for this Weber Summit. Anurag was a leader.
Yeah.
So I talked on 2 sessions, one by Anurag, second by Thangraj.
Yeah.
Convey my, what I'm talking now, basically just same with examples of my cardiovascular models.
Yeah.
Heart failure model, I was trying to sell my argument. But I think unless a society, and more important, politicians in any country, it doesn't matter whether it's India or UK or whatever, or USA, every country has problems. You can see USA it has got more problems. UK, India has got India being a very vast, heterogeneous, variable country, different state, different languages. So it's not easy to convince everybody in one go. I think, but we from scientific community or what you call clinical scientific community need to really have a proper agenda ourselves. And I'm sure eventually through media and through society, everybody will come on board. And I think
one of the positive things that has happened in pandemic, suddenly the importance of life science has gone up.
Yes.
And common people have started learning about vaccine, drugs, antibody, immunology.
I wrote,
I think all our prime ministers got educated. That's a very important thing.
I talk recently. I said, I also wrote a tweet. I said in 2005, I proposed, the book I showed you, my genomics. And
yeah, I have that.
In 2005, when I opposed the Oxford University Press, that I'm interested in this, they couldn't believe. They said, "But there's nothing there." He said, "Nothing there." When came to my help, and then he said, "Okay, we'll do it." And for many years, nobody believed. And only 2 months ago, I said, "Look, genomic medicine is here now. You could hardly diagnostic application. You're talking about this antiviral drug. It is like therapy.
Absolutely.
Developing mRNA vaccine. What is this? Full genomic medicine now, complete.
Yes, absolutely right. So, this is what has happened, that this pandemic has even given a clear understanding to even the politicians who are not educated enough that this is important. This is a strategic knowledge. And therefore, I feel very proud. I say that if 25 years back, I would not have run around for like a headless chicken to get genomics in India, today we wouldn't have been able to handle it. We wouldn't have been able to handle and do diagnostics, 1 million tests a day. 1.2 million, 1.3 million tests happening in India. Nobody would have believed beginning of the year.
But Samir, I'm a bit disappointed. Recently, I was invited by KPMG. KPMG is conducted a consultancy exercise on undergraduate medical education in India. So I was invited. The rope is complete now. Document is complete. And funded by Apollo Hospitals. Sibal, Anupam Sibal.
I know.
I
know Anupam Sibal.
So in that, myself and people from Stanford and other people, we have put many models. But what I realized, the Medical Council of India, which is now replaced by NMC, their proposal of the curriculum goes back 60 years old.
Yeah.
It's got no science element. It has got no biotechnology. It's got no genetics and genomics.
Yeah, it's a serious problem. That's why IGIB has started this program, which Anurag has started to train hundreds of young people to supplement the knowledge beyond the exams and syllabus. You are right. This is where our problem is.
Program, because I gave a talk in one of his seminars. Physician scientist, something like that. I think.
Yeah.
Welcome India DVT.
That's right.
I gave a talk in one. Yeah, anything like that would be very useful. But I think coming.
Yeah.
And people are talking about in terms of, say, other complementary therapy people. There's nothing wrong with the complementary people. If India is a vast country, many people can be accommodated. For so long, they have some good foundation. It's not fair that somebody is practicing homeopathy or whatever pathy, and they have got background knowledge is very poor. You know what I mean?
Yeah. Our basic education of in the MBBS and is definitely needs a different level. Although there are programs, but I can tell you the kids are so smart these days. They all know that this is the future. So what I'm seeing, they are not bothered about the curriculum. No, they are learning online. They are learning online lots of things.
It's important for to pass examination.
Yeah.
I think.
See, that's why their focus. It's very interesting. It's happened in IIT also. Students have segregated the two. This is exam pass, and that is learning. Learning, go to Coursera, MIT. Learning, go to medical education across the world, available online. So this online digital transformation has made students empowered to get the best teaching. Today YouTube, you can learn so many things. I had a 15 days virology course in February, all by myself. I never worried about virology. When COVID happened, I said, hey, this is going to hit. We need to apply genomics. IGIB should be forefront. So I started reading, and I just saw so many YouTube. And then I call Anurag and say, hey, we should be in the forefront. This is your time. This chance will not come. Institute can forever be established, this opportunity. So today it is possible to learn, okay? And that's why I am confident that these kids are bright.
Yes.
They know how to use digital platform. They will learn. I was just talking to a young girl, is only in high school. She explained to me COVID, cytokine storm. Okay. I listened and then I asked, where did you learn all this? She immediately WhatsApped me the links. He said, it's a cartoon link by which this has been explained. I said, oh my God, this is amazing. Yes. So these are the kids who are different. That's where my hope. So I always say, beyond the university system, beyond the government system, the kids will figure it out. And we will have enough talented kids. The question is, how do you retain those kids and give them opportunity and get them excited about real life research problems and demonstrate that science can be an exciting profession while you contribute to the society? This is and not making money is fine, but making money is not all that is important. Medical profession is not just to make money. And that, I think, a transition is almost there, according to me. So I say 2030, you will get lots of young people who are smart, who has self-learned, and with medical degree as well as scientist This is 2030, my agenda in India.
Well, that's, I think, it's very reasonable and it's achievable. 2030 is only 10 years away.
Yeah.
I think 10 years is to today's high school student who's 15, 16.
Yeah.
Be your postdoc in 10 years' time.
Yeah. And this is the one who are going to make a difference. I can see that.
So
I can see, yeah. And the Indian Institute of Science Education Research, the ISERS. See, every science was coming from Indian Institute of Science to produce people or aims. Today we have many IITs, many ISARs, and I can tell you, these students are fantastic. One of my students who last year went to Oxford, and this boy has done a lot of genome analysis with me during his master's program. He used to come from Mohali and we did. So when this COVID came in February, first 200 sequence, I said, why not we analyze? Let's see what it is. So he did the analysis and then he presented it in Oxford because he's a PhD student, first year, and everybody was surprised. Oh my God, this guy can do all this, okay? Today, he was called into the Oxford vaccine group to do analysis, right? I keep talking to him. Such a brilliant, so these kids are getting the best exposures and they know now living standard in India is very good. You get your Domino's pizza and everything. You will not miss anything or, yeah. And you can get imported cheese, you can get everything anywhere available in the world, best things you are available. Plus you have Indian benefits, like somebody will drive you a car, somebody will take care of your garden. So you see, so those privileges also exist, is a coexist. India is a very interesting country where 4,000 years of civilization coexist. Here is a guy who goes to Ganges, deep water, do some pranayam, comes up, and then talks on cell phone and transfers some money on internet. So we are a very complex. It's very difficult to understand this. So my feeling is this is where the opportunity is, and I think people like our job is mentoring them and giving them opportunity and say where to go, how to go.
That's why I bring people from all over the world.
Yes.
So 2 conferences I organized in AIMS, cancer genetics. Oh, that was fantastic. About 1,000 people. And then the AGI at Chandigarh, cardiovascular. So people are very, very interested.
Yeah. And I think lifestyle disease in which your interest, cardiovascular and all, I'll tell you, I think COVID has taught us people actually has become healthy. I don't know how, but it has just turned out people have taken adequate rest. People have taken adequate exercise because they were afraid of getting infection. And they have also eaten food more at home and they have traveled less. All this put together, this is an interesting study. One should understand and try to figure it out. What is the implication of this slowing down life and bringing it more digital life? How has it affected cardiovascular, diabetes, and other diseases? And I believe this is also an opportunity for traditional medicine and modern medicine convergence from curative care to preventive care. So as our understanding of molecular understanding takes place, we should be able to move into a preventive care so that we know there is a predictive possibility and there is a preventive possibility. And modern medicine is mostly come when you have a disease and you want to treat it, the symptoms. Whereas traditional medicine, you will be surprised now, the sale of traditional medicine during COVID has gone up because everybody wants to improve their immunity, immune booster, health food, and nutrition. So whole complete cycle and opportunity has come. So our European Union project, in which P4 medicine and compendium is actually, we are talking about how, I think we have 2 publications on that to show how it can transit by converging Western and medicine. I recently did some analysis of 500 and or 70,000 patients who are taking traditional medicine and complex diseases. And this is, I think, the first time a big data analytic paper has come. So Preventive Medicine Journal. So where we are able to show that you can see the people, 43,000 people who are obese, treated for obesity. And there is 50,000 people who are diabetic. And you can see it is just the pattern is shift of the age. The guys who are obese today is diabetic tomorrow. So you can actually stop. So all these patterns are amazingly similar, that you can see how cardiovascular with diabetes, everything gets converged as the age progresses. So I will send you the article. It has been published last year. So you can have a look that this is the first time traditional knowledge digital data we use from a company, Jiva, who does telemedicine, and their prescriptions and all this data we had, we analyzed it. And so that's where I think the future is. Yes. And this is opportunity for looking at. And I think clinical trial has to be changed. It has to be genomic molecular medicine-based clinical trial. We know Herceptin doesn't work for more than 56% of the women. So we can do a diagnostics and run and then give the treatment. Well, so same way we should work on it. If you do everybody you suppress the immunity by giving steroids and think that they will be okay, no cytokine storm, it may be wrong, right? I was asking a question that if I have got infected already COVID and I'm primed with the antibody, should I take 2 injections or 1 injection? I was discussing with the, those who are Serum Institute people, because the R&D director happened to be my student. So I was saying, what is your suggestion? If you have got infected, should you be taking 2 or 1? When I talked to the DGI SEMA, he said, actually, nobody has formed such protocol. I think we need to change this whole concept of protocols. We should create, okay, you are infected with COVID, then we'll give you 1 injection. Yeah. You are not infected, maybe you have 1.5 injection. This is what the future we need to look at.
I think that's correct, and that requires multiple small piloted random.
Absolutely, absolutely.
Not like the large.
Yes. No.
Population groups. Not only.
Correct.
Then only you get the answer.
Homogeneous population group. You should ask those questions.
I mean, okay. What I meant, say
there
are 20 states you're talking about. So
it doesn't make sense.
And 20 small piloted trials.
Yes, it will give the results. You tell me, why in Bihar, death is so small in COVID? And COVID infection is so quickly recovered. It is an amazing data. But they're doing so much of tests. They're doing 1.5 lakh tests per day. But so there is a genetic component of our immune system, which is somehow differentially gives protection. So our understanding has to be holistic, not fragmented.
I think that calls for my point. I think if you get a small piloted group, randomized.
Yep.
You need to have their genome sequence. It's not expensive.
Yeah.
For the baseline genome sequence.
Yeah.
For what are they doing, their lifestyle and all those things. You'll get.
Yeah.
But you need to
absolutely
have one parameter.
You are right.
That parameter should be genome sequencing. Then you have other things added. There's a lot of scope of fantastic research. And that's one of the objectives which I think I'm trying to bring together. UK-India Genomic Medicine Alliance. Hopefully, I'm hoping that early new year we'll have a consensus conference. Most likely it was virtual. I've got people in the USA, they are waiting, and of course, people in your place, many
Sure.
scientists and also clinicians. Yeah, I mean, it's a good time, I would say, good time for us.
It's a good time. It's a good time because public has seen variability. We haven't seen this extent of variability so visible. See, HIV, it happened, but HIV, we said, okay, it is stigmatized and some specific purpose. We knew HIV, you might get infected, but you don't get AIDS. But it was not.
HIV research got hampered because of the background background media information. It became like a taboo.
Yeah, it became a taboo. It's a social problem.
Acceptance, people getting for trial or controls was very difficult. But in this, there's no taboo. There's no taboo.
That's right.
People have suffered.
President of the country, prime minister of the country, everybody has got the disease, came recovered. So it has different, no taboo at all. So this is a perfect, I will say, socialist platform of human disease. It is not discriminated rich and poor. Your cardiovascular diabetes are rich and poor people difference. TB and malaria is a poor people disease, so that differentiation is gone. And this is a unique situation where we actually understand that biology at the holistic level is important. Because human body is not parts of anatomy, neurology, cardiovascular. This is a single machine, and that machine functions in a coordinated fashion, and we need to build a system level understanding of the health and disease.
Well, Samir, it has been a real pleasure talking to you. I think amazing. I knew some of your background, but not that much. And I think you're taking, as you said, you memory lane yourself.
Yes.
I'm really forced to remember.
Thank you very much. Thank you. Keep in touch. It is wonderful talking to you. Thank you to your foundation to consider me as one of the person who's worth, whose lifetime achievement to be recorded and used for others.
I've got, as I said, a story of Thangraj, you know him very well, very exciting, And then Narendra Mehra, amazing.
Yeah.
Ishwar Verma is also coming along. And
sure.
I've got people who matter, who have really changed the scene of genetics and genomics.
Yeah.
Which S. Agarwal was around today. And he has got his own legacy. And so thank you very much, Samir.
Thank you. Thank you very much. Thank you. Thank you.
Thank you very much. Thank you.
Bye.